Okay, so I wanted to quickly go over atomic theory and atomic mass. So we'll start with atomic theory, and we first have the cannonball model by Dalton, and he found that everything was made up of particles called matter that cannot be created nor destroyed. And so he's the cheese particles guy. And we have Thomson's plum pudding model, which he was the first one to include electrons. So his model looks like this, kind of like a chocolate chip cookie. And his findings were that they have negatively charged subatomic particles, but he thought that they were on the nucleus or in the nucleus, which we know now is false. Next we have Ernest Rutherford, who did the gold foil experiment. So he fired alpha particles, which are just hydrogen particles, or protons, into a piece of gold foil and noticed that some reflected and some passed straight through. So this led him to his conclusions that atoms are mostly dense in the center and have mostly empty space around the center. Okay, so dense and then empty space. So now we have Bohr's model, which had electron rings, so to speak. And it had the positive nucleus and the electrons around the nucleus. It was our first electron configuration and showed that electrons are not on or in the nucleus. However, they do orbit around the nucleus, sort of like the planets. Okay, so lastly we have the most recent, or wave mechanical model, where the electrons are in an electron cloud, and they don't have set orbits, but are more so everywhere, kind of every direction, and they are like a cloud. Okay, so I'll briefly go over electron configuration, because I know it was a little confusing. So you have reactive elements, and those would be your halogens, your group 7s, your alkaline earth metals, which are your group 1s, and these are reactive because they need to fill their outermost shell. Unreactive elements are your noble gases, like neon, as an example. So reactivity depends on your electron configuration, or your electronegativity, which means your affinity for electrons. And this just means that elements that are extremely reactive have a very high electronegativity, meaning they want electrons. They want to gain an electron, and then in some cases, like the group 1s, they would want to lose an electron. They really just, they have that affinity for them, and they want to fill their octet, or their valence shell. So your valence shell is just your last electron shell. And the configuration of electrons is 2, 8, 8, 32, 64, like it just keeps going up like that. Yeah. So parts of an atom, you have your atomic number, which is the number of protons, and therefore the number of electrons. So helium has an atomic number of 2, meaning it has 2 protons and 2 electrons. The number of protons is equal to the number of electrons, and the positive protons cancel out the negative electrons, meaning the whole atom is neutral, but the nucleus is positive. Atomic mass is the protons plus the neutrons. Helium 2 and has a atomic mass of 4, let's say, approximately. There's 2 protons, 2 neutrons, and 2 electrons. So isotopes are elements that have the same atomic number but different atomic mass due to different different neutrons and same protons. So let's take carbon, for example. Carbon has the same atomic number, same number of protons, but different number of neutrons in carbon-12 than it does in carbon-14. Okay. So carbon-14 has 8 neutrons and 6 protons, meanwhile carbon-12 has 6 neutrons and 6 protons, which makes them isotopes. So, when finding the atomic mass of all the carbon isotopes, you just have to average them. So you do the weight slash mass, which is the same thing, times the percent of abundance, and then you add them up. So you're always using percent. So say the carbon was 60% abundant, you would do 0.6 times the mass, and then you add those numbers up, and you get the average mass.